this talk is about how you can speed up your tests. I assume that's the topic you're interested in. My name is Mohan. I work for Electric Cloud. Electric Cloud is one of the sponsors and one of the founders of DevOps Enterprise. I run R&D and product management for a product called Electric Accelerator. So as we go through this presentation, I'll give you a little bit of a peek into what Electric Accelerator does. I assume some of you have heard about it. And so the goal of this talk, the title, I've changed the title slightly, is as we look at DevOps, we are talking about continuous delivery, continuous integration, speeding up the release cycle. So I haven't seen a lot of discussion around how do you keep the quality as you try to increase the velocity of your releases and what the cost of that is. And so the question is, are we sacrificing, so the question to all of you is, are we sacrificing comprehensive testing in order to get releases out faster? How many of you think we're sacrificing comprehensive testing or not doing adequate testing? I just see a couple of hands. I see a few more now. So that's the premise of this talk. I'd like to keep this talk interactive. It's 30 minutes, but feel free to stop me if you have any questions. And I'll try to get through this and leave some time in the end for questions. So this is a 20-year-old slide. And what this slide shows you is that the longer it takes you to find a defect, the bigger the dollar value is. And so the question to you is, do you think with DevOps and all of the stuff we've been doing, things have gotten better or have they gotten worse? So if you find a bug in field during, let's say, your beta or your test trials, it takes you $1,000. If you find it in the field and you have to issue a hot fix, you have to put out a maintenance release, it's 20 times as much. Right? So this I just wanted to show this to kind of set the context for what I think was true 20 years ago, is still true today, and it's even more relevant. Any comments, any observations from your side on this? Okay. So the question is, the situation is that, when you look at some of the most well-known recent boo-boos we have in software, it's not a laughing matter, right? So you have what happened with the government. You have what happened with Nitrida. This is actually a fascinating story. This is the company called Knights Trading. This was the company which was doing the high-frequency trading for all of the retail brokers. And they had a bug in their algorithm, and it kept buying and selling stocks for 30 minutes continuously. And they lost $440 million, and the company was sold in a fire sale. It no longer exists today. I mean, I'm just kind of trying to show you, you're all aware of what the impact of having a bug out there in the field. So, and then you also know about the recalls that you hear about from all the automotive companies like Ford and Volkswagen and GM, and these are all the software bugs that. So the problem exists today as well, and these are some of the well-known problems. The problems you might be facing in your day-to-day work may not be as dramatic, but I'm sure you all agree that we can do a lot better in trying to find the bugs before they get out into the field. So what do we need to do? I think take a minute to read this cartoon. I think the first thing that needs to happen, whether it's with DevOps or with testing or continuous integration or continuous delivery, is that we need to kind of take this seriously. It can't be that, you go to your management and say, I want to develop an automated testing system, and then you get an answer where they're not taking you seriously. And that's something that is expected to be done on a best effort basis. You need commitment from your management team to do allocate resources to it and treat it as a first-class citizen as a priority. Try working smarter, not harder, with a sense of urgency and a bias for action, or maybe you could do something differently. So again, I think you're all aware of these things, but I just want to emphasize what's happening with DevOps is now let's get it out the door. We want to get, product management has made a commitment to get all of these features out the door, and you want to make sure that all of those are delivered. And if you don't have enough time, we'll test it later. And most importantly, I think what's happening also is, because there is all of these KPIs around how short your CI cycle time should be. It's like, oh, the static analysis or code coverage, it takes too long. Let's take it out of the CI cycle. We'll do that not during the CI cycle, but we'll do that as pre-release testing. So the longer and longer you postpone doing all kinds of testing, the more bugs accumulate, and then it gets harder to find them. And any comments, any questions, any feedback on this? So this is again making the point that, look, you have your CI cycles getting smaller. It's you have 1 week sprints, 2 week sprints, and as your sprints get smaller and smaller, then you start questioning, do I really need to run the unit tests as part of the CI cycle? Do I need to run static analysis or code coverage? So the kinds of tests I'm talking about today are the tests that should be, I think, part of the CI cycle, and how we can make them go faster. And so basically, I think we have a unique challenge because there are targets around how fast your CI cycle time should be. And developers are not as motivated to write tests. All of the reasons associated with this. And as a result, I think more and more you saw the curve, the farther out in the cycle you find the bugs, the more it's going to cost your business. Okay, so this is a quote from Martin Fowler that I like. They say, try to speed up the commit build. This is your pre-flight build, before you check stuff in. You want to run a build just to make sure that you're not breaking anything out there. And the magic number that I hear a lot of customers talking about now is 10 minutes. I want to get my CI build time down to 10 minutes. And so he says here, this requires some pretty serious surgery on your code base as you break dependencies on slow parts of the system. But most often the surgery is to remove the tests that are taking the longest time and that are probably the most valuable. So like I talked about, these are the tests that should be run as part of continuous integration on a continuous basis, whether they be unit tests, static analysis, or code coverage. So we can find the defects earlier in the software development lifecycle and provide faster feedback to the developers. So here are what I've seen are the typical fixes when your CI cycle gets too long and you need to address the fact that your tests are taking. How many of you have seen some of these typical fixes in your organization? One or two of these. So the first one is saying, let me figure out, oh, these are the group of tests that I can divide into 2 or 3 parts, and let me find a server to run these tests, kind of manually split them up. And I don't like the word manually because your tests are continuously changing, you're increasing the number of tests you have, and as a result, this process is not going to be scalable. It's not something you can do on a consistent basis. How many of you have seen manually parallelizing your tests? that's going on. Right. And then the second one is, let me get beefier machines. And then you often see that you get beefier machines, you have 64 core machine, but your tests don't go faster because you're limited by how fast how much parallelism you can extract, or whether they can even be parallelized or not. And I think the most common one I see is that you accept the long CI cycles. There's nothing I can do. My code base has gone to have millions of lines of code. I have tens of thousands of tests. And we really have this charter to make sure the quality is highest. So what if it takes 3 to 4 hours? That's the cost of the complexity of the software. And what happens as a result of that? Your developers, who are your most valuable resources, they run a build, and then they say it's coffee time or lunch time, and then probably run maybe 1 or 2 iterations per day, and that's a huge drain on your productivity. And then the last one is also very common. I've seen that, where you basically say, static code analysis doesn't belong as part of CI. Why do I need to run code coverage? What value do I get from that anyway? And you take them out of your CI cycles. So the question you're asking, so as you can see, these are all bandages, and this is not an ideal solution. But the question is, what can you do about it? So this is another interesting cartoon I'll let you read. So you have a lot of defects, and then you get to the end of the release, and you have a date to meet. Say, why don't we put them in the future bucket as enhancements, and let's ship the release. Let's put them in the release note. So where do I start with fixing and making sure my tests run faster? The first answer, obviously, this is what you've heard a lot at DevOps, I'm sure, hundreds of times, is automate everything, and especially automate your tests. Automation by itself gives you a huge amount of acceleration, because you don't have there's an anecdote I've heard from one of our field engineers, is they went in and they said, do you have a script for how to run your build? They said, yes. And it turns out the script they were talking about was not a shell script. It was kind of like a movie script. They had a list of steps of how to run the build. So I think automation means different things to different people. You definitely want to be able to say you have a test framework and you're adding tests using that test framework. This is like 101, but I just want to reiterate that that's the first step in this journey to get your tests going faster. And that by itself gives you a significant amount of acceleration. So I think I'll just get to where there is also coarse grain parallelism, but I'm kind of skipping that. Coarse grain parallelism says, I'm going to run this suite of tests on this specific machine, and you try to load balance across a different set of machines. But wouldn't it be ideal if you could have a system which were able to understand the tests at the lowest level and run as many of these tests as you can in parallel? And so that's kind of where I'll get a little bit deeper into. How many of you are doing fine-grained parallelism on your tests today? Awesome, I see one hand. How about coarse-grained parallelism? And how many of you are skipping tests that you should be running more often? Okay, so there's definitely a one-time cost when it comes to, so obviously this doesn't come without some upfront cost, right? So you have to invest to be able to kind of set up a system where you can get this fine-grained parallelism. And I'm going to talk about what the recipe for that could be. while I'm going to talk about electric accelerator, since that's our baby, but that's something you can implement yourself. So what are the three ingredients you need in order to be able to do this fine-grained parallelism? So the first thing you need is you need a way to list all your tests, enumerate all your tests. Do you have a command you can run and say, these are all the tests I need to execute? The second is you need a command where you can say, here's how you execute a single test. Right? And then you need some kind of a workflow to tie this together and say, run this iteratively on these set of things. So that's kind of the premise of what this fine-grained parallelism is about. And so there's some upfront work for you to be able to set it up so you can do this fine-grained parallelism. But once you do it, I think you'll reap the benefits by being able to run your tests in a fraction of the time, as I'll show you with a few real-world case studies that we have implemented with our customers. Questions, comments? I'd love to hear some feedback. That way I know you guys are. So how many of you have heard about electric accelerator? So electric accelerator is the product that Electric Cloud was started with. It is a system that helps you to parallelize any tasks. It's most well known for its ability to speed up builds in the C, C++ area that are using makefiles. But the reality is that it's agnostic to what the payload is. It can accelerate anything as long as you can, like I said, be able to define jobs that need to be sped up. And you can define these jobs in either a makefile or a YAML, and then you can feed it to Electric Accelerator, and then it figures out how to load balance them in the optimal way across a cluster. And this, you can do this across physical CPUs or cloud CPUs. And the key word is safely. I'm not going to get too much into the product aspect of it, but if you have any questions, come talk to me about Electric Accelerator afterwards. So just a little summary of what the product does. We've seen speedups as much as 20x when it comes to builds and tests, as I'll show you with some of my case studies. Even if you're running a fairly parallel process, like using -j, and you're using all the cores in your machine, now you're able to extend it across multiple machines. You're able to efficiently use a cluster of resources that you have to run multiple jobs. And then the automatic dependency detection, this is the secret sauce in the product, which is watching the file system, which is watching the registry, and seeing if the jobs are run in the right order. And if they are not, it makes sure. So when you're parallelizing it, can I depend on the fact that the tests are being run correctly? And the answer is yes. And again, I'm not going to go into details. I'll allow to talk to you offline if you have interest in that. And then the key thing, I'll show you some examples, is at the end of that run, you can see a visualization where you can see where the time was spent, how your tests were parallelized, and what the bottleneck in your tests are. And most often, you have one test that's taking the longest time, or a number of things that are the critical path, or what we call the longest serial chain in your process. And we have a way to be able to visualize that, and for you to go address those so you can shorten your test times and then make efficient use of resources. I think this is another very important criteria when you're trying to get into accelerating your tests, is you need to be, compute is cheap today, but still you need a way where you can spin up, let's say you're using EC2 instances, or you're spinning up containers, you run your tests, and then once you're done, you can dispose of them so that you don't have any zombies lying around and you don't get any surprise bills. So all of these are capabilities that are built into Electric Accelerator. So this is a little bit more visualization on how Electric Accelerator works. So you're submitting a bunch of tests. These could be tests from your Android or Selenium tests or some other tests that you have in-house. And so essentially the client piece submits these test suites, if you will, to the cluster manager, and that decides which set of resources are available to fulfill that test. You can see here that you're combining all of the cores you have in your cluster, so the tests are executed on a per core basis, so you get to use, that's what I mean by fine-grained parallelism. And you can run all of these tests concurrently because there's load balancing that the cluster manager helps you to achieve. And when there's a priority test that comes in, it can even preempt existing tests that are using those resources. You can define a resource pool that certain tests have higher priority over, and that's how you get your tests completed in the shortest possible period of time. So I'm just going to go through 3 case studies I have on how customers were able to use Electric Accelerator to speed up their builds. And so the first case, this is a customer who wanted to use the Martin Fowler 10-minute. They had all of the CI cycle, and their unit tests and code coverage was not letting them get to their 10-minute cycle. Let me build this out. So you can see the results here is they were sticklers for test-driven development. They needed to keep their cycle time low. The tools they were using was Bullseye for code coverage, Boost, that's a C++ library, and the tests were taking 7 minutes, 30 seconds. During the evaluation, they ran it on 2 machines, and then they were able to see that they could cut the time down more than half to 3 minutes, and then the best case time, if they had infinite resources, they could go down to 39 seconds. So most likely you're not going to put 100 cores to use for it, but you can figure out what the optimal number of resources you need to get to that sweet spot you're looking for. So you can see this is the visualization I talked to you about from the tool that's called Electric Insight that comes with Electric Accelerator. On the left-hand side, you see the time elapsed. That's the x-axis. The y-axis is each of the agents that are running the tests in parallel. Each of those little rectangular boxes represents a job. And so you can see that it's so tightly packed across these 5 agents. And then on the right-hand side, you get a simulator. If you don't have resources, you can plug this into the simulator and say, what happens if I add 50 more cores? How much would my test go down to? And it says, look, you can get down to 39 seconds if you were willing to put 50 cores on it. So you kind of get some visualization without having to set it up, how fast you can go. Any questions on this? So this was the first use case, which was about unit test, code coverage, and being able to speed it up. That was in a Windows environment. The second use case, which I think should be applicable and interesting to a lot of you, is we hear a lot like, oh, I have hundreds of types of browsers I need to support, and my Selenium tests take a long time. And so many people, we have heard from customers that they're not running their Selenium tests. And so here's what happened. We took a batch of 100 tests, and before it would take almost 30 minutes. And then after running it through Electric Accelerator on 2 machines, we were able to cut it down to under 4 minutes and 27 seconds in the best case. So how many cores? They were 8 cores, I believe. There's a video on our website on how this process works with Electric Accelerator. You basically, instead of you run Selenium in kind of headless fashion, there's a driver called Selenize where you can execute a single Selenium test. And like I said, so there's a recipe we have shown where we can show you a demo of how exactly this was done. So you can see, you can, especially because tests don't have much dependencies in them, unit tests Selenium tests, these are ideal candidates for parallelization because tests are ideally supposed to not depend on other tests. They are supposed to not depend on the output of a previous test for their test. That's how your developers are supposed to write these tests. Even if they do, our dependency management can help and catch that. But my point here is that tests have a lot of parallelism built into them that they can use to speed up their builds. So the last use case, I'm going to build this out completely, is we had an existing customer and their static analysis with Parasoft was taking too long. And again, we were able to use, we have two interfaces or on-ramps to Electric Accelerator. We were able to use this one which can capture processes that are being invoked repeatedly and ship them off to the cluster. And you can see that the build time was cut down to 1/5 of what it was before. So that's pretty much the three use cases I was going to talk about. Here's a little flavor. I'm sure many of you are curious. This is all very high level. Can you tell me exactly how this works? So here's a sample, YAML file, if you will, that you can feed into Electric Accelerator. So here's the two things you need is how do I run a single command? And that's what the command is going to give you. And then the second one is how do I list all the tests in my suite? And so you can either make this. So that's our way. We know like a lot of folks are afraid of working with makefiles. So our goal is to make it simpler so you have a YAML file, everyone feels comfortable with that. So if you want to use that interface, this is the process, the upfront work I was talking about you have to do in order to A, enumerate all your tests, and B, provide a way to run a single test, and then kind of encapsulate them within this YAML file. So these are the tools we have tested with. You can see the static analysis tools, the code coverage tools, and some C++ unit test frameworks that are well known. It could probably work with your test framework as well. But it'll require some work on your front to make sure. So I think I just want to summarize what does doing all of this buy you. So the goal here is if you can parallelize your tests, you can have shorter CI cycles, and you don't have to sacrifice test and coverage and analysis during your CI cycle. And you can scale no matter how large your code base grows or how many more tests you get. We went to a customer and said, our goal is we have about 1,000 tests, system tests right now, but our goal is by the end of the year, we want to get them to 10,000. So the number of tests you have will keep growing. And so you need a way to be able to contain how much time it takes. Otherwise, the problem is only going to get worse. And we talked about hardware is cheap, but you definitely want to be able to see how you can make the most efficient use of your hardware and continue to use your existing tools. It's not realistic to say, let's put everything into this new test framework where you can do test avoidance. That's a buzzword you'll hear a lot about. Can you figure out which subset, when you change some code, what subset of your tests need to be run? Because it's all built into your build system, but that means you have to re-implement everything. So you are manually tagging that these are the tests that need to be run for this set of code changes. So I've heard that a lot, but I think that's really kind of a holy grail for most cases. It's not simple to figure out with your existing build system what subset of the tests are adequate, necessary, and sufficient. And then you can, like I said, if you implement the system with something like Electric Accelerator, you will not only be able to speed up your tests, but you can also get visibility into what's taking the longest time, what their dependencies are, and you can give feedback to your developers as well. No, I'm not saying that. I'm saying that there are some new build systems which allow you to capture that kind of information as part of it. But I have no electric accelerator is assuming that all of the tests that you're supplying to it have to be run in parallel. So the last part I want to mention is, this whole journey to shorter CI cycles is a journey. You have your build, your test, your deploy. That could take weeks if you are doing manual handoffs. The first step is you want to automate everything tied together. I'm sure you all have. And then the next phase is that if your builds and tests are taking long, you need to look into how you can shrink those so that those are not your bottlenecks. And that's how you go from weeks and days to minutes. Thank you very much.